7.3, we're going to talk about properties of logs. So first thing we're going to talk about is the change of base formula. Most calculators, you can't change the base, or the base being that little number. If we had to take the log base 2 of 10, most calculators don't have the ability to change the base when we put it in the calculator. So the change of base formula says that we can take the log of 10 and divide it by the log of 2, and that would be the same thing. So the base is always going to go on the bottom. We can do this with logs or with the natural log, so with ln. So if I had the log base a of x, we would say the ln of x over the ln of a. So these are the same thing. They'll give you the same value. When we put a log in our calculator, if it doesn't give you the option to change your base, let's say I was taking the log of 2, and it doesn't have a base on it, it doesn't have a little number down here. Does anybody remember what's implied that the base is? 10, awesome. Our base is 10. So that is the common log with the base of 10. So in example 1, it just wants us to write in ratio of the common log and natural log. So if I were to put this in the calculator, I would have to do the log of 16 over the log of 3, or we could say ln of 16 over ln of 3. Then you would just divide it in your calculator. Same thing for, it says a again, but this should be b. We would take the log of 22 and divide it by the log of 5. So the base always goes on the bottom. Or to do the natural log, we would say the ln of 22 over the ln of 5. These would give us the same value. Next, we're going to talk about our properties of logs in expanding and condensing our log functions. So if we were multiplying two terms together, we're taking the log of two things that are being multiplied, we can expand it with addition. Every time we break it apart, each one's going to get its own log. If we were dividing, we would expand it with subtraction. And if we have an exponent, we can expand our log by moving the exponent to a coefficient. And then we can use these same properties when we're condensing it. If I was adding two logs together, I can condense it with multiplications. We can go the other way too. And then the same properties work if we had natural logs instead, if we had ln's instead of logs. Example 2 says, write each logarithm in terms of ln of 2 and ln of 5. How would I make 10 in terms of 2 and 5 using either multiplication, division, or exponents? What could we do? Well, first we would want to say that 10 is 2 times 5, right? And what goes with multiplication? Addition. So we would say the ln of 2 plus the ln of 5. So this just wants us to write in terms of ln of 2 and ln of 5. So here I'm dividing. How could I change 32 to be in terms of 2 and 5 using either multiplication, division, or exponents? Awesome. I could change 32 to be 2 to the 5th power. Perfect. So this is ln of 5 over 2 to the 5th power. Now, since we're dividing, how would we break this apart when we have division? Subtraction. Awesome. So this would be ln of 5 minus ln of 2 to the 5th power. And what would I do with the exponent? Put it in front. But it's just the exponent on the 2. It's not an exponent on the 5 also, so it just goes in front of that ln. So we have the ln of 5 minus 5 times the ln of 2. In example 3, we're going to look at C and D. So here we're doing the same thing. We're going to expand our logs. So we have log base 5 of 25 divided by x times y. So I'm going to start with the division. What did we say goes with division? Subtraction. So log base 5 of 25 minus log base 5 of, what would come next? X. And then what?
And then you can add them, and then you do plus log 5y.
So if I said plus log base 5 of y, is y on the top or is y on the bottom? Y is on the bottom. So would it get a plus or a minus? It should get a minus. Because y is on the bottom, it's actually being divided. Even though it looks like it's being multiplied times the x, it's actually being divided in the big picture. So it would get a minus. If you wanted to leave it as a plus, you could just put this in brackets or parentheses. And that would be the same thing. But if we distribute the minus, we would get log base 5 of 25 minus log base 5 of x minus log base 5 of y. So these two would be the same. You could write it either way. But if you left it as a plus sign, you need to have those parentheses. We can actually simplify this a little bit more using things that we talked about yesterday. Log base 5 of 25. 5 and 25 are kind of related. 25 would be 5 to what power? 5 to the second power. So if I change 25 to be 5 to the second power, what is log base 5 of 5 squared? What happens when we have the same base and the same number here? They cancel. So what would this be equal to? 2. So our answer, our final answer would be 2 minus log base 5 of x minus log base 5 of y. Another way that we could have simplified this here is we could say log base 5 of 25 is equal to x. We could rewrite this into exponential form. So we could say 5 to what power equals 25. And we said that was 5 to the second power. So log base 5 of 25 is equal to 2. So that's why we replaced it with the 2. So when you're simplifying or when you're expanding and condensing, just make sure you simplify it all the way. Any questions here? All right, let's do D. So I have division going on. What goes with division? Subtraction. So the ln of e cubed minus the ln of 8. Can we simplify this anymore? We could bring the 3 to the front. The exponent would go in front. We have 3 times the ln of e minus ln of 8. What is the ln of e, or what does the ln of e simplify to? 1. The ln of e is just 1. These cancel. So we're left with 3 minus the ln of 8. So anytime you're taking the ln of e, it simplifies. Anytime you are taking the log and your base and what you're taking the log of have a common base, make sure you simplify that too. So you want to simplify these all the way. On the next page, we're expanding. So when we look at e, here we have 9 that's raised to the 4th power and x that's raised to the 4th power. So if you want to bring the 4 in front first, then anytime we break this apart, we're going to keep the 4 with the log. So here we have 4 times log base 3 of 9. What goes with multiplication? Adding. So plus 4 times log base 3 of x. Can I simplify this anymore? Yeah. Log base 3 of 9 is going to simplify. 9 we can say is 3 to what power? 3 to the second power. So I could change this to be 3 to the second power. So log base 3 of 3 cancels. So we're left with 4 times 2. So this would be 8 plus 4 times log base 3 of x. Any questions there? Awesome. For f, when I have a square root, how could I rewrite that as an exponent? 1/2. I'm going to rewrite this to the 1/2 power. So when I split this up, since we're dividing, what goes with division? Subtraction. So ln of 4x plus 1 to the 1/2 power minus the ln of 8. And then what would we do with our exponent? Bring it to the front. So we have 1/2 times the ln of 4x plus 1 minus the ln of 8. That 4x plus 1 is just one term there. It's one thing, so we can't split that up. Since it's in parentheses, we just keep it. If it was just a 4x without the plus 1, we would want to split it up since they're being multiplied. But because we have that plus 1 there, it just makes it all one thing. We can't break it up anymore. So this would be our answer. So an example 4, we're condensing. So any coefficient I have, I want to put that as an exponent. So it's just going to be an exponent on the log that it's attached to. So here I have log of x to the 1/3 power. What goes with plus? Multiplication. So times x minus 3 to the 5th power. Let's simplify this a little bit more. I want to change the exponent back into a radical. What type of radical would we have there? The cubed root. So we'd have the cubed root of x. So log of the cubed root of x times x minus 3 to the 5th power. We're going to do the same thing in b. The 4 is going to go on the x minus 4, and the 2 is going to go on the x. So here we have the ln of x minus 4 to the 4th power divided by, because we have subtraction now, x squared. Any questions here? Awesome. C, I'm going to work inside the parentheses first. Since that 1/5 is outside of the brackets, everything's going to be raised to the 1/5 power, or the 5th root. So I'm going to combine these first with multiplication. We have log base 3 of x times x minus 2. And then we can raise it to the 1/5 power or put it under the 5th root. So this would be our answer. In 7.4, we have exponential and logarithmic equations. So we're going to use the properties that we learned in 7.2, 7.3, and we're going to be solving equations now. So we have one-to-one properties. I think it explains all of these, yeah, on the next page. We're going to look at the next page here. So anytime we can make the base the same, this is a one-to-one property, we can cancel out the bases and then just set the exponents equal to each other. So if I had something like 2 to the power of x is equal to 32, and we can make the bases the same, you want to make the bases the same because then they'll cancel, and we just set the exponents equal. Same thing if I have a log is equal to a log, or if I have an ln is equal to an ln. This only works when you have one ln or one log on each side. We can't just cancel out if we have 2 on one side. So here they just add the ln to move it to the other side. So we have an ln equals to an ln. They'd cancel. We'd say x is equal to 3. C is similar to A, where we just wanted to make the bases the same. When the bases are the same, they cancel. We set the exponents equal to each other. With D, anytime x is in an exponent, we want to use logs to help us get the x out of the exponent to solve. So here, what's going to cancel out with the e is the ln. So I'd want to take the ln of both sides, because that'll cancel. We have x is equal to the ln of 7. In the next one, it's kind of the opposite. Since I have the ln, I'm going to use exponents to help me. So I'm going to make the big base e on both sides. E to the power of ln will cancel. So I'm left with x is equal to e to the power of -3. F is similar. What's the base on the log that I have for f? If the base isn't written, what's our base? 10. So since this is a base of 10, we'd want to make the big base 10 on both sides, because 10 to the power of log base 10 would cancel, so we're left with x is equal to 10 to the power of -1. And then g is the same, but here our base is 3, so I'd want to make the big base 3. 3 to the power of log base 3 would cancel. We're left with x is equal to 3 to the 4th power. So for something like a, we'd want to make the bases the same. How could I make the bases the same? What do you think our common base between 64 and 32 would be? So if we said 64, we could say is 2 to the 6th power times 3x. How would I make 32 be 2 to what power? That would be 2 to the 5th power, and then we would just multiply it by the exponent that's there, 2 plus x. Once our bases are the same, we can cancel them and then just set our exponents equal to each other. So here we would have 18x is equal, this should be 10 plus 5x. There we go. So we can subtract 5x on both sides. And we get 13x is equal to 10. And then divide by 13. X is equal to 10 over 13. Good there? Awesome. So C, we want to get the base with the exponent all by itself. I'm going to add 9 to move it to the other side. So e to the power of x is equal to 28. To get the x out of the exponent, we want to use our logs. So I'm going to take the ln of both sides, since the ln and e are going to cancel each other out. So we're left with x is equal to ln of 28. For the web assign, just put in the ln of 28. That would be your answer. So you just put it in your calculator. E is a little bit different. Well, actually, it kind of starts off the same. We would just cancel out the e's. We have negative x squared is equal to 5x plus 6. Here, we're going to have to factor since we have an x squared and an x. So I'm going to add x squared to move it to the other side. So we get 0 is equal to x squared plus 5x plus 6. What are two factors of 6 that add to 5? 2 and 3. So we have x plus 2 and x plus 3. So x is equal to -2 and x is equal to -3. Any questions here? What about for D? Here I want to get my bases to be the same. What could I do to make the bases the same? How could I change 1 over 25 without changing the value of it? How can I just change the way that it looks to have the base of 5? 5 to what power would be 5? would be 1 over 125. The third power? Negative third power. Because the negative would make it a fraction. The third power would make it 1 over 25. So 5 to the power of negative 3, this is equal to 1 over 125. Make sure you're not changing the value of it. One of the most common mistakes that people make with these types of questions is that they would change the 5, and it would change the value. You just are changing the way that it looks. You're not changing the actual value of it. So then we have 5 to the power of 2x. Our 5s are going to cancel, so 2x is equal to negative 3. So x is equal to negative 3 over 2. Let's look at g. So just like I said before, we want to get the base with the exponent all by itself first. So here I want to add 4 to move it to the other side. This would be equal to 15 and divide by 2. So 3 to the power of 2x minus 5 is equal to 15 over 2, or we could call it 7.5. Can I make these have the same base? Can I change 7.5 to be 3 to some exponent? No, we can't. So what we would have to do here, when we can't get them to have the same base, we have to use our logs. So I'm going to take the log base 3 of both sides, because log base 3 of 3 will cancel. So we have 2x minus 5 is equal to log base 3 of 7.5. For the web assign, you'd put this in the calculator. We're just going to solve it, do the steps without putting it in the calculator. So next we would just add 5 to move it to the other side, and then divide by 2. So x is equal to log base 3 of 7.5 plus 5 over 2. And you just put this in the calculator. All right, let's look at h. So h is a little bit different than how we did e on the last page, where we just made our e equal to our e. They canceled each other out, so the exponents equal to each other. We can't just get the e's to equal here. But this one's a little bit special because it looks like x squared minus 3x plus 2. But instead of x's, we have e to the power of x. So when we have x squared minus 3x plus 2, we would solve by factoring. So we're going to factor here. But instead of having x's, we have e to the power of x. If you want to use substitution and substitute, you could substitute u into your e to the power of x. You could do that way, but we're just going to factor like we would normally. What are two factors of 2 that add to negative 3? Negative 2 and negative 1. So instead of saying x minus 2, I'm going to say e to the power of x minus 2 and e to the power of x minus 1 equals 0. Next, we're going to set both of these equal to 0. So e to the power of x minus 2 equals 0 and e to the power of x minus 1 equals 0. Then we just solve each of our little equations here. E to the power of x is equal to 2. How would I solve for x from here? Take the ln of both sides. Perfect. So x is equal to the ln of 2. For the next one, we're going to add 1 to move it to the other side. E to the power of x is equal to 1. We do the same thing. We're going to take the ln of both sides. So x is equal to the ln of 1. With these types of questions, especially with all of the solving ones, you can't take the ln of a negative number, or you can't take the ln of 0. So if you were to factor this and you end up taking the ln of, let's say, -2, that would not give you a solution. So you can't take the ln of 0, and you can't take the ln of a negative number. Any questions here? Okay, I think J would be a good one to look at next too. So for J, what would we do here? Can I get -4 to be 2 to some power? No. So we'd want to use logs. If we can't get the bases the same, we want to use logs. So I would take the log base 2 of both sides. So log base 2 of 2 would cancel. I'm left with x is equal to log base 2 of -4. How would I use the change of base formula to put this in the calculator? Which one would go on top? -4 or 2? Log of -4 over log of 2. Remember, the base goes on the bottom. Can I take the log of a negative? No. Just like we can't take the ln of a negative, we can't take the log of a negative. So this would be no solution. I think on WebAssign it tells you to put not possible. Just make sure you read the directions on what it wants you to type in. But this one would be no solution. Yeah. So just like before, when we want to get the base all by itself, we also want to get the log all by itself when we're solving. So here I want to divide both sides by 2. So then we have log base 5 of 3x is equal to 4 over 2, which is 2. Now how can I get rid of the log? We want to use exponents to get rid of the log. You can either rewrite this in exponential form, or we could just make the big base 5. So 5 to the power of log base 5 would cancel. We're left with 3x is equal to 5 squared. So 3x equals 25. X is equal to 25 over 3. For C, we said if we have a log equals a log, we can cancel them out, but it doesn't work if you have more than one log on one side of your equation. So here, I want to condense the left side just to be a single log. How would we condense when we are adding? Look. Awesome. We would use multiplication. So we take the log base 3 of x times x minus 2 equals the log base 3 of x plus 4. Once we have a log equals a log, they're going to cancel. And then I can just set what I'm taking the log of equal to each other. Here, when I distribute, I'd get x squared minus 2x is equal to x plus 4. What would I have to do to solve? Put everything to one side because we're going to have to factor. Subtract x and subtract 4. So we get x squared minus 3x minus 4. This one factors, but let's say, hypothetically speaking, if it didn't factor, what would we have to do? We'd have to use the quadratic formula. So this one factors, but I know that you guys know how to factor, so we're going to move on. What about for A on the next page? What would I do here to solve? What cancels out an ln? E cancels out ln. So I'd make the big base e here on both sides. E to the power of ln would cancel. We're just left with x is equal to e squared. For WebAssign, put e squared into your calculator. That would be your answer. For B, since we have a log equals a log, these would cancel. Just set where we're taking the logs of equal to each other. So 5x minus 1 equals x plus 7. What about for C? Could I just cancel the logs here? No, we got to condense it just to be one log on the left side. How would I condense with subtraction? Divide. So we have log base 6 of 3x plus 14 over 5 is equal to log base 6 of 2x. Now that I have a log equals a log, they cancel. So 3x plus 14 over 5 is equal to 2x. And then we would solve from here. I can multiply both sides by 5. So 3x plus 14 is equal to 10x. (14) is equal to 7x. Divide by 7. X is equal to 2. One thing that you definitely need to do is check your work, especially when you have logs. Remember, we can't take the log or the ln of a negative number. So when you have a question like this and you have logs, you always want to check your work. You can just lightly plug it in. You don't have to solve it all the way, but just make sure you're not taking the log of a negative. If I take 2 and plug it in, 3 times 2 would be 6 plus 14 is 20. Is 20 a negative number? No. So it works. And then if I plug it into here, we're taking the log of 4. 4 is not a negative number, so it works there too. So you can just lightly plug it in, see that you're not taking the log of a negative, so then you know that it works. So anytime you have a question with logs, make sure you check your answer.